So this is Math 114, 5.5, dividing polynomials. Objective 1, use the quotient rule for exponents. The quotient rule states, when dividing exponential expressions with the same non-zero base, subtract the exponents in the denominator from the exponents in the numerator. Use this difference as the exponent on the common base. So this one shows that here we have base b and base b, which is the same base. That means when we have the same base, the exponents will subtract. And remember that b cannot be equal to 0. Why is that? Because this would make this undefined. So on this one we have divide the expression using the quotient rule 512 divided by 5 to the fourth. So since we have the same base, I can say that this is 5, 12 minus 4, which is 5 to the 8th. Divide the expression uses the quotient rule again. Okay, so we have our base, which is x. That means that since we have the same base, the exponents will subtract. So this becomes x 9 minus 2, which is x to the 7th. Objective 2, use the zero exponent rule. So the zero exponent rule says that any base or constant, anything to the 0 power is always equal to 1. As shown here. 5 to the 0 is 1. 2xy to the power of 0 is also 1. Now this one, these two, which is this guy and this guy, have a little difference. This one became completely 1 because of the parentheses. The parentheses stating that everything goes to the 0 power. However, this problem right here, only the y has the 0 power, so therefore the 2x remained. Similarly, this last problem, the 0 power is only going to the 2, not the negative. So this becomes negative 1. Use the quotient to power rules. Like the multiplication, that means that the exponent will distribute. So it says, if a and b are real numbers and b is non-zero, then when a quotient rule is raised to a power, raise the numerator to the power and divide by the denominator raised to that power, meaning that you distribute that n. So we have here 5x to the 4th to the 3rd over y squared to the 3rd. Now, recall that when we have a base and a power to a power, then they multiply. Therefore, we have 5 cubed x 4 times 3 over y 2 times 3, which becomes 125, x to the 12, y to the 6. 3b states, simplify the expression using the quotients to power rule. So this becomes 2 to the 4th, a to the 40th, over b to the 12th, because of the same process we did before. Now 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16a to the 40th over b to the 12th. Divide monomials. To divide monomials, divide the coefficient and then divide the variables. Using the quotient rule for exponents to divide the variable factors, keep the variable and subtract the exponents. So here we have 5 times x to the 7th over 10x cubed. So this becomes 5 over 2 times 5 times x to the 7 minus 3. Why is this happening? Because the base of x is the same. The 5's cancel, so I have 1/2 times 7 minus 3 is x to the 4th, and that's an answer. But if you want to put it together, it's x to the 4th over 2. So let's see how this one goes. So we have 2 times 3, x 5 minus 3, y cubed minus 1 over 2. I just separated the 6 into 2 times 3. We have a base of x on both top and bottom, so the exponents will subtract, so 5 minus 3. We have a base of y, which is 3 and 1, therefore the exponents will subtract. So the 2's cancel out, so I have 3x, 5 minus 3 is 2, 3 minus 1 is 2. Divide a polynomial by a monomial. Dividing a polynomial that is not a monomial by a monomial. To divide a polynomial by a monomial, divide each term of the polynomial by the monomial. That was a lot. So what this is telling you is that, first of all, let's remind a little reminder. When we have b divided by a, this becomes b over a, which letter becomes this. So this is something we have to remember. So this becomes 40x to the 4th y cubed minus 20x cubed y squared minus 50x squared y divided by 10x cubed y cubed. This I can rewrite as 40x to the 4th y cubed over 10x cubed y cubed minus 20x cubed y squared over 10x cubed y cubed minus 50x squared y over 10x cubed y cubed. After this, we're going to be treating each and every single one. After having this, we're going to be treating each and every single term separately. So that 40, I can break it into 4 times 10. And then I have x cubed times x times y cubed over 10x cubed y cubed minus 2 times 10 x cubed y squared over 10 x cubed y squared times y minus 5 times 10 x squared times y over 10 x squared times x times y squared. Now after this we can cancel, so the 10 goes away, the x cubed goes over with the x cubed, the y cubed goes over with the y cubed, so I have a total of 4x left over. Minus the 10's cancel out, the cubes cancel out, the y squareds cancel out, so I have 2, and on the denominator I have leftover of a y. Minus the 10 cancels out, the x squares cancel out, and the y's cancel out. So that means that I have in the numerator left of a 5, and in the denominator I have left of x times y squared. So, again, similarly, I can separate those things into every single term. So now I have negative 15x to the 9th over 3x squared plus 6x to the 5th over 3x squared minus 9x cubed over 3x squared. This I can rewrite. 15 becomes negative 5 times 3 times x squared times x to the 7th over 3x squared plus 2 times 3x squared times x cubed over 3x squared minus 3 times 3 x cubed over 3 x squared times x over 3x squared. So the 3 goes over with the 3, the x squared goes over with the x squared, so I have negative 5x to the 7th plus the 3 cancels, the x squareds cancel, so I have 2x cubed minus One of the three cancels. The x squares cancel. 3x.